So for number one, we look at what it is we are looking for. We're looking for this side here. So we have to look at what do we know. Now, we either have to know one angle other than the right angle, or we have to know two sides. Do we know an angle here? Yes, we do. I mean, we either know an angle or we're going to be looking for an angle. It's always going to be that. So we know an angle. According to that angle, the x that we're looking for is which side of this triangle? Opposite. The 27 is the adjacent. What trig function is that? Tangent. So tangent of an angle equals opposite over adjacent. So we plug in those numbers. We have the 38 or 38 degrees, that's the angle. Opposite side is x and the adjacent is 27. We're going to put this over 1 so we can cross multiply and divide. So tangent of 38 degrees times 27 divided by 1 gives us 21.09. That is inches. Is that what you guys came up with? Any questions? Okay. Reflections? Oh. Now, in number 2 here, do we know an angle? No. Are we looking for an angle? Yes. So this is the angle we're looking for. According to that angle, the 32 is which side? Opposite 42? Hypotenuse. The 42 would be the hypotenuse regardless of the angle we're looking at. So anyway, opposite and hypotenuse make sine. So sine of an angle is opposite over hypotenuse. We don't know the angle. X is the angle. That's what we're looking for. The opposite is 32 and the hypotenuse is 42. Here we are looking for an angle rather than a side. So how do we solve it? Inverse sine. Since we're using a sine, it's an inverse sine. So the sine and inverse sine cancel out. X is the inverse sine of 32 over 42, which gives us 49.63 degrees. How many of you had that? Anybody have any questions as to how we got that? Jordan, you look confused. Number 3, you guys tell me how to do it. Okay. Okay. It is a tangent. We have an opposite over adjacent. So yes, it's going to be tangent of x equals 8 over 25. And then what? Perfect. Inverse tangent. Ian gets his gold star for the day. So x equals, what'd you get for an angle? (17.74 degrees). Wonderful. Number 4. Not picking on you, Jordan, but tell me how to do it. According to this angle, what sides do we have? What's the x? Adjacent, thanks Ian. And the 14 is the hypotenuse. Good. Adjacent hypotenuse make up what trig function in your little note sheet? Adjacent over hypotenuse is the cosine. You are correct. So, as we write this out, do we know the angle? Yep, that's the 27. Do we know the adjacent side? No, that's our x. Do we know the hypotenuse? Yeah, we better. We can only have one thing that we don't know. So we're looking for a missing side, so we make it a proportion. Put that trig function over 1. It is now cosine of 27 times 14 divided by 1. course, we know we don't have to actually divide by 1. Cosine of 27 times 14 is going to be 12.47 inches is that missing side. What do you guys think? That's finding those missing parts of a triangle that we talked about before we went on spring break. And we actually had looked at some where we had shapes within a situation. So today I want to look at a shape that looks like this. I'm going to be smart and draw my circle first. Or he's hunched down. So a radius of, let's say, 8 inches. This angle here, let's say that's 70 degrees. Let's say I want to know the distance from, well, if I give you that this is 6 inches, I want to know the distance from here up to the top of the ball. That's what I'm looking for, is X. So my big question here, where's the right triangle? Yeah, our rules of circles, remember, is a radius of a circle to a point of tangency forms a right angle with that tangent. So if I draw the radius out here to these points where the circle is tangent to these lines, those form right angles. Does that look familiar? Tangent always forms a right angle with a radius. Now, another lesser known rule is if I take a line from the center of the circle, a line segment, I should say, from the center of the circle to the point where those two tangents intersect, what does it do to that figure? Well, it creates two equal triangles. This is a radius and that's a radius, so those two lengths are equal, right? This length is equal to itself, so the hypotenuse of each of those triangles is the same. And when we're dealing with right triangles, if two sides are the same, the third one has to be, because of the a squared plus b squared equals c squared. So anyway, what we have here is I'm going to look at just one of these triangles. I'm going to look at that one. That's a right angle. This side is 8 inches. What else do I know about that triangle? How'd you get 35? Yeah, if those two angles are equal, it cuts the 70 in half. So that's 35 degrees. So now, which side of this triangle am I really interested in finding? Well, if I look at x here, that height x, it's really in 3 pieces. It's this piece here, which we're given is 6. This piece from here to here, which is just a radius of our circle of 8 inches. What other piece do I need to find? That hypotenuse from here to here. I'm going to call that A. We need to find that. I'm going to be careful. I'm going to call it C because it's across from the right angle. It'll be less confusing that way. How do I find C? Yeah, well, this is the opposite side, and this is the hypotenuse, so it is going to be a sine. And of course, I do usually write out the definition. Sine theta equals opposite over hypotenuse. Do I know the angle? Yes, I do. 35 degrees. Do I know the opposite side? Yes, that's the 8 inches. The hypotenuse, of course, is what I'm looking for. Let's see. So I'm looking for a missing side. So I put my trig function over 1 to make it a proportion. Now here's where doing that makes it, is important because I know I'm going to cross multiply and divide. I have 1 times 8 is 8, and that it is 8 divided by the sine of 35 degrees. giving me 13.95. Inches. So X is going to be found by taking 8 inches, that's the top one, plus 13.95 for that one, plus 6 inches for this piece, which is going to give us 27.95 inches is X. What do you think? Better than a sharp stick in the eye? I'm gonna have you guys try one. Let's say our radius here is 20 inches. Let's make this angle here 110 degrees. Let's make this distance here 15 inches. This distance here 35 inches. I want to know X here. How far does that round piece stick out above the surface of that block? Assume everything is symmetrical here. So I'm going to give you guys a little bit of time to give that a shot. Why not? Okay, let's say a peek. So we're going to do the exact same things we did last time. Just our final answer is going to be found from a little bit different spot. So we still have those right angles from the radius, the radii to the tangents. If we cut this down here, it still makes two equal triangles. This angle is going to be, well, let's just focus in on this triangle quick. What's this angle here going to be? 55. What side do we know here? The opposite here, the radius, which is 20. We are looking for the hypotenuse. Let's call that C. So this is going to be a sine again, because we're dealing with opposite and hypotenuse. We know the angle of 55 degrees. Opposite of 20 inches, we're looking for the hypotenuse. So 1 times 20 divided by the sine of 55 gives us 24.42 inches. And of course, this is still 20 inches on the way up. So we add together those 3 dimensions, which is going to give us, what, 59.42 inches? Does that look right? Subtract the 35 to get from here to here, gives us 24.42 inches. Any questions? How about a shape like this? Let's say I'm going to give you that, oh, let's see here. Let's say that I tell you that this is 40 feet. This here is 16 feet. The radius of our circle is, let's go 14 feet. I want to know the length of fence to go around this piece. If I'm going to go all the way around this, in other words, find the perimeter. So we're assuming these lines are tangent. So I'm going to draw one here that makes a right angle to this piece. I'm going to draw one here that makes a right angle to that piece. This is 14 feet. This is 14 feet. What can we do from there? You know what? The only way this one can work out, I've got to be careful. I'm going to change this radius to be 16 feet. That's the only way this problem can work out without using oblique triangles. So each of those is going to be 16 feet. If I don't make that equal to this, we're going to get a oblique triangle. Get ugly. So now I can connect this across here. What's that length? Yeah, 40 feet. It's just a rectangle. How do I find this distance? Yeah, a squared plus b squared equals c squared. I'm just going to do the square root of 40 squared minus 16 squared. Why is it minus? Yeah, we're finding a leg. We have the hypotenuse and we're going backwards to find a leg. So 40 square root of 40 squared minus 16 squared, 36.66 feet. Well, now what? We'd add those three up, but we still need to know the length of this arc around here. To know the length of that arc, we need to know that angle, don't we? We know that angle is less than 270 because that's 90 degrees there. Where did I get 270 from? Three, 360 minus 90. If we knew this angle, we could do 360 minus 90 and minus that angle, give what's left over. How would I find that angle? Perfect. The adjacent and the hypotenuse I would use. Why don't I want to use the 36.66? It's rounded. Yeah, it's one we calculated and it's rounded. If I can go back to exacts, I want to go back to exacts. So that's going to use cosine, which is adjacent and hypotenuse. So let's put in what we know. We don't know the angle. That's what we're looking for. The adjacent is 16, the hypotenuse is 40. So since we're looking for the angle, we're going to use inverse trig. Our inverse cosine of 16 divided by 40. 66.42 degrees. So that is 66.42. Adding that to the 90 degrees that we had there, 90 plus 66.42 is 156.42. Any questions on where the 156 came from? That's the angle from here to here. Now then we're going to subtract that from 360, which is going to give us 203.58 degrees. That's this angle here. Now what? Well, there you go. We have to find the circumference. The circumference is going to be pi times 32. Where did 32 come from? Diameter. Double the radius. So 100.48 feet. What am I going to do with that? There you go. And you could set it up as a proportion and cross multiply. I'm just going to multiply the 100.48 times the ratio of that degrees. It's 203.58 out of 360. So times 203.58 divided by 56.82 2 feet. So we have 56.82 feet. So we're going to add up here 40 plus 16 plus 36.66 feet plus 56.82 feet. So that's 56, 112, 142, 148, 149.48 feet, correct? What do you guys think? Good stuff? Okay, we're going to give you guys some stuff to work on. Since you guys are gone tomorrow, it's going to be a little bit longer assignment. I fully anticipate we're going to have to do some of these homework questions in class on Wednesday. That doesn't mean blow them off and don't try them. But that does mean if you get stumped on one, don't like pluck your eyebrows out trying to figure it out. This is out of your book. So out of your book, page 749 through 754. Exercise 35-2. 1 through 17, the odds. Also out of your book, page 760 through 763. Exercise 35-3. 1 through 15, the odds. Now I realize that's only 16 or 17 problems, but like I said, some of these are pretty tough. So try them, give them an honest effort, but don't be afraid to punt and come back in on Wednesday and we'll go over them. Listen, if you're stumped on one, don't sit there for hours staring at it. Yeah, what's Wednesday? Interview day. You guys get your interview scheduled during my class? I got you.
I got one at 1 o'clock.
They'll be here for the first 15 minutes. You won't be here at all?
I'll be here for 30.
Well, we'll record it for you.